This session is a survey of automated peak tracking with Fusion QbD. When developing chromatographic separations, peak retention can change, including coelution and retention order shifting. Therefore, using only the concept of the critical pair to evaluate the quality of the separation can be ambiguous, as the particular analytes involved as critical pairs can change. Alternatively, when specifically tracking all peaks with a Fusion QbD PeakTracker, you are able to identify and track the behavior of all peaks, including the deconvolution of partially or completely coeluted peaks, peaks with identical mass, and non-ionizable and non-UV absorbing peaks. This provides important knowledge to support method lifecycle management. The automation tools include all of the water's chromatographic systems controlled by Empower, including solvent and column selection valves and the PDA and SQD detectors. In this session, we will cover 3 basic steps to provide automated peak tracking. First, chromatograms are processed with only good basic chromatographic processing in Empower. Second, data are imported into Fusion QbD. And third, automated peak tracking is performed with Fusion QbD PeakTracker for statistical analysis and determination of optimum method conditions. We'll first cover basic processing in Empower. From Empower, review the Empower sample set generated by the Fusion QbD generated experiment. Select the best looking chromatogram, for example, the one with the most separated peaks. Develop a processing method with appropriate basic integration parameters. You do not need to name chromatographic peaks. Enable system suitability and save the processing method for the UV channel. From the sample set, review the MS channel of the same chromatogram used to create the UV processing method. From this channel, create a mass spec processing method. Once satisfied with the integration, save the MS processing method. Both the UV and mass spec channels must be processed into a single result set. To process both the MS and UV channels simultaneously, create a method set containing the UV channel and a derived MS total ion chromatogram channel and their respective processing methods. Check the Save MS Extracted Channel box and save the method set. Use this method set to process the sample set into a single result set. Review the Empower results from the result set and correct any errors. Displaying the UV and MS channels in a stack plot aids in processing. For more information on processing chromatograms, see the Empower Data Exchange Guide in the online help in Fusion QbD. To import the results from Fusion QbD, select Import Responses and log into Empower using your Empower credentials. Select the project containing the experimental results and select the desired result set. Select the PDA channel that was processed. Enable PeakTracker data import. In this example, there's an analyte that doesn't absorb UV but ionizes in the mass spectrometer. Select the PDA channel in the MS channel. Enter the time offset between the PDA detector and the mass detector. Click Track Non-Absorbing Peaks and Next. If any of the trend responses are selected, select None and click Next. Fusion QbD displays the imported chromatograms for easy reference and review. Notice the peaks are identified with the label of unknown in the order of elution, though none of the peaks have been identified and tracked. To track peaks, start PeakTracker from the menu bar. Fusion QbD displays stacked UV and total ion chromatograms. Select the experiment run used to create the processing methods in Empower. Select Create Tracking Method and from this run only. PeakTracker displays a table of peaks with retention times and mass data, and you may now identify the components by their component names. Notice that we have labeled a peak with H star to indicate a peak that ionizes in the mass spec but does not absorb UV. To assist with peak identification, both UV and mass spectra may be displayed. Click Track Peaks for all runs. Peak labels are now displayed on the UV chromatogram. Review each chromatogram and make changes to peak assignments as needed. Notice that PeakTracker automatically identifies co-eluted peaks and corrects assignments and responses to reflect co-elution. Click Update Data and close PeakTracker. Review the chromatograms and notice that Fusion QbD has automatically assigned component names to each of the peaks and has also indicated the position of the non-absorbing peak relative to the other peaks in the chromatogram. The data are now ready for statistical analysis, modeling, and visualization. For more help with PeakTracker, view the online PeakTracker User's Guide. Although only the position of the non-absorbing peak is shown on the imported chromatograms, after modeling, Fusion QbD incorporates it into a scaled peak into its prediction chromatogram. Thank you for viewing automated peak tracking with Fusion QbD. To learn more about Fusion QbD, contact sales@smatrix.com.